Hey folks, just thought I'd look at a few of the items I asked you to do on the lab quiz. Wanted to make sure that you saw correct answers for some of them before we met again. And the first one was number 1, part B. Let me write down what the function was. The function was f of x equals 1 over x plus 1. And you were asked if this function has an inverse function. Okay, on 1A, I think everyone got that correct. Everyone said no because it failed the horizontal line test, and that's fine. But remember, you can't tell me the answer to the question is yes because it passes the horizontal line test. I could make a graph that lies to you. What you have to rely on when you look at the graph and you really believe it passes the horizontal line test, and so you believe it does have an inverse function, you have to rely on calculus. In particular, you have to determine the derivative. And, well, you know, here the derivative of the function is negative 1 over x plus 1, that quantity squared. And then when I look at that derivative, I just kind of think, well, no matter what number I put in for x, the denominator is going to be positive. The numerator is negative. Negative divided by a positive is negative. So just from seeing the derivative, I can make the claim that the derivative is negative. And technically, it's negative everywhere on its domain. So let me write that down. It's negative on its domain. That tells us the function is decreasing on its domain. If the function is always decreasing means it's monotonic, or more importantly, it tells us that the function is 1-to-1. And once we know it's 1-to-1, that's what tells us that an inverse function exists. So just kind of remember that if you look at the graph and you believe it passes the horizontal line test, you have to do a little bit more work to verify that it really does. The next one I thought we would look at was number 3, part E, getting the derivative for the function. Let's see, the function was inverse tangent of 3 over x. Okay, now this one I told you I wanted you to simplify it down to a single fraction. So here I go getting the derivative. I employ the rule for derivative of inverse tangent. So the derivative of inverse tangent, that gives me 1 over 1 plus that 3 over x quantity squared. And now the chain rule. The derivative of 3 over x is negative 3 over x squared. And now when I clean this up, this isn't too bad. You'll see how we come up with a single fraction. I get 3 over x squared, that's 9 over x squared. So now when I take this mess and I multiply it out, it's numerator times numerator, so that gives me a negative 3 over denominator times denominator, which gives me an x squared plus 9. And that's all there was to 3e. The next one I thought wanted to make sure you're all dialed in on was number 4, part C. Here you were asked to integrate natural log. Well, that says natural log the 5th of x over x. But what I want you to realize is seeing natural log to the 5th x. It just means nothing more than the natural log of x to the 5th power. That's what it means. So for this one, what you needed to do was, and a lot of you, I'm going to write off here to the side what a lot of you told me, and it's not going to work. A lot of you told me that you were going to let u equal 1 over x, and then you said somehow du would be ln x dx. Folks, that's not true. If u is 1 over x, du, well, du would be the derivative. So du would be a negative 1 over x squared dx. So, when you get the lab quiz back on Monday, you're going to see a lot of, red x's like that and just all kinds of craziness happen. So here's how I would do the problem. Just a basic u-sub. I would let u equal ln x. Then du is 1 over x dx. And then after I make my u-sub, I'm just left with integrating a u to the 5th du, which is 1/6 u to the 6th plus c. Resubstitute gives me 1/6 natural log to the 6x plus c, or if you prefer, 1/6 the natural log of x to the 6th power plus c. The next one I thought we would look at, and it's going to be the last one, because all in all, you did a pretty good job on the lab quiz. We're just kind of tightening up a few little issues. Actually, it's the second to last one, was number 4, part E. And this was a minor issue. You were asked to integrate 2 over a 16x squared plus 25 dx. And I was happy to see that all of you knew that this was going to be an arctan creature. And a lot of you actually started off by saying, well, you're going to rip that 2 out front. And you saw the 16x squared as a 4x quantity squared. And 25 is a 5 squared. But here's where we have that little issue, and I tried to always warn you about this, that, in our general arctan formula, we can see here that a is 5, u is 4x, so that tells us du is a 4. Whoops. Let me erase that. Oops. It's good if I actually get an eraser. It tells me that it's a 4 dx, or 1/4 du is dx. Remember, I always, Monday when we did a lot of these problems, I kind of stressed that you have to identify what u is. And for a lot of problems, if u is just x, du is dx. But here du is 4 dx, so 1/4 du is going to be dx. All that means is that when you crank this through your formula for arctan, you're going to have that factor of 2, and then that's going to be multiplied. Oops, sorry about that, folks. That's going to be multiplied by the 1 over 5. So it's multiplied by the 1 over 5, which is also multiplied by a 1 over 4. That 1 over 4 is coming from the fact that dx is 1/4 du. And then, everyone I think had this inverse tangent, 4x over 5 plus c. But when you multiply the 2 times the 1/5 times the 1/4, you're going to get a 1/10 inverse tangent 4x over 5 plus c. So this is just a little tightening up problem. Most of you had 2/5 inverse tangent 4x over 5. And I just wanted you all to see, that it's not a 2/5, it's really a 1/10. Okay, now it's time to look at the final one. And this will be the final one because it's the last one that's on the lab quiz, which was integrating 1 over x square root 1 minus the natural log of x squared. I think a lot of you looked at this and you thought it was number 3 in the theorem that I wrote on the board on Monday, and it most definitely is not that. If you look at that theorem carefully, it says when you integrate a 1 over u, square root u squared minus a squared, You know, what's under the radical here is not a u squared minus a squared. It's an a squared minus u squared, so it is not number 3. But if you look at what's under the radical and you see that as an a squared minus u squared, that should remind you of the formula for inverse sine. And it is the formula for inverse sine. If you start off by letting u equal ln x, then du is 1 over x dx. And then when you substitute in, that gives you the integral of 1 over the square root of 1 minus u squared du. And the antiderivative of 1 over square root 1 minus u squared is nothing more than inverse sine. And then you resubstitute, and you get inverse sine of ln x plus c. So folks, that's it. Just a very quick screencast on a few of the items that, you just needed a little bit of cleaning up on. So hopefully that makes sense. Hopefully you give this a look at before class on Monday. Have a good weekend. Thanks for watching.